Inshallah, I'm going to start. I'll do a quick video about lesson 9.2, understand theoretical probability. This is the second lesson in this topic. So quickly, we have two main ideas. First, we need to find theoretical probability. We need to understand how can we calculate the theoretical probability. And the second idea is how can I make prediction. So if I have the theoretical probability of an event, how can I predict how many possible outcomes are going to be out of some total number of repetitions. Okay, so let's start with the first idea. So theoretical probability, which is basically probability of a specific event to happen. We have here three different events: rolling a dice, spinning a wheel, rolling a dice here, spinning a wheel, and flipping a coin. So probability of a specific thing to happen. How do we calculate it? It's basically theoretical probability. How do we calculate it? We just look for number of favorable outcomes, and we need to divide by total number of possible outcomes, which is basically the same probability that we used to find the previous lesson. We call it theoretical probability because this is in theory. This is what we expect. This is not the exact future for this event. We're just theoretically speaking that this is gonna happen or whatsoever. Okay, so let's talk about the first event. Find the probability of flipping a head. So when you flip a coin, what's the theoretical probability of getting a head? So what's the number of favorable outcome? Number of favorable outcome is basically how many times we have head. When we flip a coin, it's either head or tail. So we have one time head out of what's the total possible outcomes? There are basically two possible outcomes. 1 out of 2. That's it. Here, probability of landing on an even number. So we are looking for what's the event? It's an even number, okay? So what's the favorable outcome? How many even numbers we have? 1, 2, 3, 4, 5 even numbers. Out of how many is the total possible outcomes? All of the numbers are 10, basically 10 sections in all. 5 out of 10. Here, what's the probability of rolling a number less than 3? Less than 3, okay? Oh, this is cute. Anyways, it's basically how many times we have in a dice, how many times we have number 3, a number that is less than 3. The outcomes are either 1, 2, 3, 4, 5, and 6. Which one of these are less than 3? 1 is less, 2 is less, 3 is not less. It's equal to 3. So I have two outcomes, two favorable outcomes. Out of how many is the total number of outcomes? Is basically 6. 2 out of 6. That's it. Same here. When you roll a dice, what's the probability of rolling number 4? Again, the outcomes in a dice is basically 1, 2, 3, 4, 5, 6. How many of them are number 4? It's only one time. 1 out of 6 possible outcomes. Here, rolling even number. Which one of these are even numbers? Number 2, number 4, and number 6 are even numbers. So basically they are 3 times out of 6. Odd number. The other 3 are also odd numbers. So basically the other 3 out of 6. Can you see? Rolling a number more than 1. So all of these are more than 1. So 5 numbers are more than 1. So 5 out of 6. Probability, this is P, probability of rolling a number less than 5. Now, which ones are less than 5? Basically, number 4, 3, 2, 1. So basically, how many? 4 numbers. 4 out of 6. Here, it's if they're gonna ask about likelihood in the previous lesson, I can say here it's unlikely. This is halfway, so we call it equally likely. Also, this is half of 6, which is equally likely. If you remember, this is likely, high chance of getting this. It's just more than half. Also, this one is more than half, so it's likely. okay. Six-sided dice, blah blah blah. So basically when you roll a dice and get an odd number, we said it's basically 3 out of 6. So probability, or theoretical probability, is the same as the probability that we used to find, okay. Here we have this event. Spinner has 8 equal size sections. To win the game, the pointer must land on a yellow section. So what's the probability of landing on a yellow section is basically 2 options, 2 times. Out of all of them are how many? 1, 2, 3, 4, 5, 6, 7, 8. When you count the total, you count everything, including the yellow. 2 out of 8, or I can say it's basically 1 out of 4 in case you want to simplify it, or if you want to make it as a percentage, it's 25%, but you don't have to. Here, a game board, let's do this question. A game board has a spinner with 10 equal size sections, okay? 4 are green, 3 are blue, 2 are yellow, and 1 is red. What is the sum of the probability of the pointer landing in green, blue, yellow, and red? So basically in all sections. Probability of landing on any of all sections. Since there are 10 sections, then it's basically I might land on any of them, 10 out of the total is also 10. Okay, which is basically 1. This is a certain event. It's certain that it will land on green, blue, yellow, or red. Okay, so if you want to do it this way, you can. Another way is basically you can calculate the probability for every single event and combine them. You can say probability of landing on green is 4 out of 10 sections. Probability landing on blue is 3 out of 10 sections. Blue is 3 out of 10 sections. Probability of landing on yellow, it's 2 out of 10 sections. And lastly, probability of landing on red is 1 out of 10. And then you can combine all of these probabilities. 4 out of 10 plus, this is green, plus blue, 3 out of 10, plus yellow, 2 out of 10, plus red, 1 out of 10. Whenever we are adding fractions, we only add numerators, only. Okay? 4 plus 3 plus 2 plus 1 is basically 10 out of, we write the same denominator, which equals to 1. It's the same thing that we said here. So you either find them separately and you will find out that the probability of landing on all these is 10, or you can do it by logic. You know that these are all the sections, they're asking all the sections, so it's basically going to be all of them out of the total, which is the same thing. Explain, basically you're asking for all the sections. Landing on any of all sections is certain event, is 100%. It's a certain event. It's 10 out of 10. It's equal to 1. It's all certain. So it makes sense. Okay. Now here, a bag contains 5 red balls and 3 blue. If one of them is drawn at random from the bag, what is the theoretical probability of selecting a blue? Blue is 3 out of, the total is what? 3 plus 5 is 8 in the bag. So 3 out of 8. This one, easy. طيب, let's cover the next idea. What if I want to do prediction? If I want to do prediction, I will need my theoretical probability and I will need the number of times I'm gonna predict. Okay? طيب, let's do it. So let's take this example. If Fatima were to flip a coin 100 times, this is the number of times you're gonna do your repetition, or you're gonna do your event. How many times she will expect to get head? This is the probability you want. Probability of getting head 400 times. So what's the idea here? You can do it simply by you either have two options. Either write the theoretical probability of getting head. It's basically one chance out of two. Then ask yourself how many times I might get head, and if I repeat it 100 times. Okay? Just organize your numbers and then do butterfly method. 1 times 100 divide by 2. So it's gonna be 100 times 1 divided by 2, which is 100 over 2, which equals to 50. So 50 times out of 100 times you might get head. This is one way. The other way is just write your probability of landing on head times the how many times you're going to repeat your event times 100. So probability of landing on head is half times 100. It's basically 50. The same thing. So either with butterfly method or multiply the probability by number of times you're gonna repeat it. Here, if Ali were to roll a dice 60 times, so out of 60 times, how many times am I gonna get the event? What's my event? He is expecting to get number 4 in a dice. Number 4 in a dice, this is probability of rolling a dice and getting number 4, which is one chance out of 6. 1 out of 6. How many out of 60? Do butterfly method. 1 times 60 divided by 6 is basically 60 over 6, which is 10. This is one way. So 10 times you might get number 4. The other way is just probability of getting number 4 times how many times you're going to repeat your experiment? 60 times. So it's basically a probability of getting number 4 is 1 out of 6 times 60 is basically multiply the 60 with 1, 60 out of 6, which is 10. The same. Okay? That's it. So for prediction, you will use your theoretical probability and multiply it by how many times you're going to repeat it. Okay? Here, in a different game, the probability of correctly guessing which of 5 boxes contain a tennis ball is 1 out of 5. They gave you the probability. It's 1 out of 5. How many winners would be expected if 60 contestants play the game? So how many winners out of 60? Butterfly method. 1 times 60 divided by 5. So it's going to be 60 over 5. 60 divided by 5 is basically 12. 12 winners. How many out of 60? That's it. Here, our friend is playing a game using a fair coin. Contestants win the game if the fair coin lands tails up. The theoretical probability of a coin that will land tails up is basically, we have head or tail, so it's basically 1 out of 2 possible outcomes. This is probability of landing on tail. If 250 contestants will play the game, so 1 out of 2 for playing flipping the tail 1 time. How many out of 250? So just do butterfly. 1 times 250 out of 2. So it's going to be 1 times 250 out of 2. 250 out of 2 is basically 125. 125 of them might win. Here, what does it mean that there is an equal theoretical probability of each outcome? So, for example, equal theoretical probability in flipping a coin. So in flipping a coin, probability of landing on heads is 1 out of 2. Probability of landing on tail is 1 out of 2. They have equal theoretical probability. Do you know what does it mean? It means that the coin is a fair event. We already discussed that it's a fair event if all outcomes have equal chance. We said that if you have a dice and all of the numbers are 1, 2, 3, 4, 5, 6 different numbers, then it's a fair dice because each one has 1 out of 6 chance, equal chance. But it's not fair if you're gonna have 1, 1, 1, 2, 3, 4. That's totally not fair because one has higher chance than the others. So once you have equal theoretical probability, it means directly it's a fair event. Why? Because we just explained it here. You can explain further. Okay? A bag contains 3 blue, 2 green, and 5 red marbles. What is the theoretical probability of drawing a red marble? A red marble is basically 5 out of, what's the total? 5 plus 2, 7, plus 3, 10. 5 out of 10. Probability of taking a red marble. Now, if you draw 50 marbles, so how many out of 50 are going to be red? Red is 5 out of 10. So how many out of 50? Butterfly method. Okay, so it's going to be 5 times 50 out of 10. 5 times 50 is 250 out of 10 is basically 25. 25 red marbles. And last question. A 12-sided solid has equal sized faces numbered from 1 to 12. So the outcomes are either 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So it's a fair event. All of them are the equal size. All of them are repeated one time. So it's totally fair. Okay? Probability of getting a number greater than 10. How many of these are greater than 10? 11 and 12. So 2 out of. These are the favorable outcomes. How many in all? 12 outcomes. Probability of getting a number less than 5. Less than 5. I cannot select 5. I want less than 5. 4 out of 12. Okay? If a 12-sided solid is rolled 200 times, so how many out of 200? I want to do the prediction out of 200, okay? How many would you expect either number 4, 6, or 9 to be rolled? So I want probability of rolling 4, 6, or 9. Yalla, bismillah. First of all, I have to find the probability of rolling. Ya imma 4 or 6 or 9. When do we have 4 and 6 and 9? I have 4 one time, 6 one time, 9 one time. So basically they are 3 out of 12 all possible outcomes. I want to see how many out of 200. Butterfly method. Okay. 3 divided by 200 is basically 3 times 200 divided by 12. 3 times 200 is 600 divided by 12 is not sure, to be honest. I think it was something related to 5, 50. 60 divided by 12 is 5 and 0, 50, yes. So 50 times you're gonna get number 4 or 6 or 9. Okay? That's it for today. Good luck.